Welcome to this video for Anatomy Explored, the human abdomen. This video is going to outline the key differences between the jejunum and ileum and also the features of the large intestine. So if we first of all start by drawing out just some representative sections of both the jejunum and the ileum. Then here we can see we've got a section of jejunum, and here we can see we've got a section of ileum. So just two representative sections, and immediately we can see that the jejunum here and the ileum on this side. The jejunum is of greater caliber than the ileum. It has a greater diameter, and its walls are also thicker than that of the ileum. It also has a greater vasculature, and because of that, the jejunum tends to be redder than the ileum, which assumes more of a pinker colour because it has a reduced vasculature. So the small intestine is supplied by the superior mesenteric artery. So here we can see just a representative length of the superior mesenteric artery. And coming off the superior mesenteric artery are going to be a series of what are known as arterial arcades. So we can see these arterial arcades here creating these boxes, this box-like arrangement where the arteries are coming off the superior mesenteric artery, and essentially what they're doing is they're running towards the small intestine, and they're running parallel to it. Because the small intestine is that much longer than the length of the superior mesenteric artery, it enables the arteries to fan out and go to the entire length of the small intestines. So we've got these arterial arcades here, and for the jejunum you can see there's a few of them in relation to what we'll draw for the ileum, and they're quite large. They form these large loops. And then simply coming off these arterial arcades are a whole series of straight arteries, also known as your vasa recta. So the vasa recta, these straight arteries for the jejunum, are very long. And when we draw them on in the ileum, you'll see that they're much shorter. So let's have a go at doing that. Again, we've got a representative length of the superior mesenteric artery. And this time we can see that there's a whole series of these arterial arcades, but they're more irregular. There's more of them, and they tend to be smaller. So here we can see we've got a representative portion of these arterial arcades, and you can see that they are considerably smaller, and there's more of them than compared to the jejunum. So here we can see we've got more of these arterial arcades, so a branch is coming up here, it's passing towards the ileum, and we can see there's a whole series of these arterial arcades, but they're smaller, like I said, and they're more irregular, but we can still see there's a whole series of them, and then we can see they're going on to supply the other part of the small intestine. So we can follow a blood vessel. It's going around here, and then it's coming up, and then ultimately it's going to give rise to a whole series of blood vessels, again these vasa recta, these straight arteries, but this time these arteries are much shorter than their counterparts for the jejunum. So here we can see we have a whole series of these vasa recta, these straight arteries, so the vasa recta again, but this time for the ileum we can see they're much shorter. Here again we have the numerous arcades, but we can see that there's more of them, but they're smaller. So here we can see some key differences between the jejunum and the ileum. We can follow a blood vessel as it passes all the way up through towards the ileum, but we can see the jejunum has these longer vasa recta, fewer but larger arcades compared to the ileum. So if we now turn to the large intestines, the various portions of the large intestines and their features, then we can tell the difference between a piece of small intestine and a piece in large intestine, primarily by its location and also by a series of external features. So let's start off by drawing out the distal portion of the ileum, and the distal portion of the ileum passes into the cecum, where it forms the ileocecal valve. So here we can see the cecum of the large intestines, this dilated pouch, and here we can see the distal portion of the ileum. So this is forming the iliocecal junction here, the iliocecal junction. And we can see that the food passing from the small intestines, from the ileum, is going to pass into the large intestines, specifically at the cecum. One characteristic coming off the cecum is the appendix. This is a blind-ended pouch. We can see the appendix here. It doesn't have a great deal of function in the human. It can store some lymph tissue. And this is its typical position, but it can also assume a number of other positions depending on the individual. So it can be displaced either to the left or to the right, or it can in fact be positioned behind the cecum. So here we have the appendix, and we can see that it assumes a number of positions. It can assume a number of positions. So if we now start with the cecum, we can see that the large intestines travels upwards. So this is happening along the right side of the abdomen, and this is known as our ascending colon. And then as it heads towards the liver, it turns to the left, and here it becomes the transverse colon. And this turning of the colon occurs at the liver in the top right, in the upper right quadrant of the abdomen, and this is known as the hepatic flexure. So the transverse colon then passes transversely across the abdomen. We can draw it out here. So here we have the transverse colon. And then it heads towards the spleen, where it then becomes the descending colon. So here we can see we have the descending colon. The turn where it becomes inferiorly from running transverse is known as the splenic flexure. And then the descending colon passes down the left-hand aspect of the abdomen, and then it heads towards the midline via the sigmoid colon. So it heads towards the midline as the sigmoid colon, which then is continuous with the rectum. So here we have the rectum, which obviously is in the midline. The rectum is continuous with the anus as it passes through the pelvic floor. So here we can see the rectum, here we can see the anus, and here we've got the sigmoid colon. So here we can see our various parts of the large intestine. We've got the cecum, which receives the ileum and the iliocecal junction. We then have the ascending colon, which turns to the left and runs transversely along the abdomen. This occurs at the hepatic flexure. Here's the transverse colon, heads towards the spleen in the upper left quadrant, and then it descends as the descending colon. It then passes towards the midline, where it's continuous with the rectum, and here we can see the sigmoid colon. So initially, before I start detailing those external characteristics, I just want to draw your attention to another important demarcation, and that is approximately here. And this is the demarcation between the midgut and the hindgut. So previously we saw the demarcation between the foregut and the midgut, and this was at the major duodenal papilla, that landmark on the descending part of the duodenum. And here we can see that 2/3 of the way along the transverse colon, we have this region, which is the transition between the midgut and the hindgut. There's no definite structure that demarcates this separation between midgut and hindgut, but approximately 2/3 of the way along the transverse colon is the midgut, and the final third is the hindgut. This is important in the nerve supply and the vasculature of the gastrointestinal tract, which we'll explore later. So let's draw out some of these landmarks, these characteristics on the external surface of the large intestine. And the first one I want to draw out is a band of longitudinal muscle. Now, the longitudinal muscle is split into 3 bands, and these are known as tena coli. They all originate from the appendix, and we can see they run along the transverse colon. So here we can see one of the 3 bands of tena coli. You have one here that is going to attach the Appendices epiplicae. I'll come to those in a moment. You have another tena coli, which is where the colon, large intestine, is anchored to the abdominal wall. And you have a free one, which doesn't have anything attached to it. So you have 3 tena coli one that attaches the appendices epiplicae, we'll come to those in a moment, and one which is in line with the attachment of the colon to the posterior abdominal wall. And we also have a free one which doesn't have anything in contact with it. This longitudinal band of muscle, you can see one of the three bands here, eventually passes to the rectum, where it then gives rise to a full covering of longitudinal muscle that surrounds the rectum. So here in blue we have our tinea coli, a band of longitudinal muscle. Now, as I mentioned, attaching to this tinea coli that we can see here are going to be a whole series of what are known as appendices epiplicae. And these are characterized, and these are fatty tags. They're little fatty outpoachings of peritoneum that is surrounding the transverse colon, and they're just these fatty tags. So as soon as you open up the abdomen and you see the small intestines, once you've located what you believe to be the large intestine, you can usually confirm it by finding either the tinea coli or these appendices epiplicae. So appendices epiplicae. And these are fatty tags that are attaching to this longitudinal piece of muscle. Because we have this longitudinal piece of muscle, and this longitudinal muscle is shorter than the length of the large intestine, it actually pulls it in and creates these saculations. So these saculations, we've got one here, these little pouches, which are created as the tinea coli are slightly shorter. The length of the tinea coli is shorter than the length of the large intestine, and that means it's contracted and it pulls the large intestines into these saculations, and these are known as haustra. You can see we have these haustra, S-T-R-A there, haustra. We can see these are all the way along the large intestines. So then finally, to finish, I just want to draw out the mesentery, the association of the mesentery to the large intestine. And the large intestine is secondarily retroperitoneal for its ascending and its descending portion. But for the transverse colon and the sigmoid colon, these are actually suspended by mesentery. So suspending the transverse colon is anchoring the transverse mesocolon, is anchoring the transverse colon to the posterior abdominal wall in line with the pancreas. We have the transverse mesocolon. We also have for the sigmoid colon the sigmoid mesocolon, and the sigmoid mesocolon is anchoring the sigmoid part of the large intestines, the sigmoid colon. So here we can see the main external characteristics of the large intestines.